For any database management system, we start with designing the database, then we deal with different types of manipulation of the data, then we filter the data using different types of normalization technique, and after that we actually collectively work on different operations and we treat it as a single unit. We call it transaction. So after doing all this kind of thing, we need to focus at how the actual data are stored on any physical media. In this topic, we will discuss different type of storage structure that we follow to store data in a database and what kind of file structure is available to organize our data on any stable storage. To store data, we have different kinds of stable storage or different kinds of memory system. We start with cache. Cache is a very small and fast device. It is made of electronic circuits and the access time is much faster than any other device in our computing system. After that, we have main memory, we usually know as random access memory or RAM. From the name, we can just realize that the access type is random in nature. Also, the storage is volatile, that is, after power is off, the data within the main memory is lost. So this kind of cache or main memory is not suitable to store. Also, the size is not so much, so it is not suitable to store entire database. Another kind of memory we have, which is also known as electronically programmable read-only memory, or in short EEPROM. This is special kind of ROM, which ROM in the form of the ROM, which know that the data persists after power failure also. So reading is very fast in flash memory, but writing is very complicated. So it has a limited number of writing cycle. That is number of time we can write into this flash memory. So after that, we have very popular device. It's called magnetic disk storage, which is used for your permanent storage. All files are recorded stored in magnetic storage, hard disk drive, we know. And the way we store actually based on some magnetic mechanism, and using this magnetic property, we store actually different kind of information disks at the physical level. After that, we have in a sequence that called optical storage. Data are written by some laser technology. We know that the popular disks are compact disks, CD or DVD. The disks in which we can actually store the data, and digital video disk, also known as digital versatile disk. So we can use this alternatively. And the last one is which is today is very obsolete, called tape storage. In this storage, a long strip is used, a long magnetic strip are used to store the data. The access is very sequential. We cannot read randomly at different location. We have to follow the sequence, and it is primarily used to backup data. So in earlier system, when the disk storage was not so much high, we actually used tape storage to backup our data. So these are the preliminary idea of different kind of stable storage or volatile storage we use in our total processing system. So depending upon their architecture and also their cost, we can build a hierarchy of our storage or memory device. So at the top we can see the cache is there. Cache actually have the top rank because of their access speed. Also, it is very costly than other devices. So after that, it comes in the hierarchy is a main memory, which is less faster than cache memory, but its cost is lesser than cache. So that's why we mostly use in our system a main memory, not cache memory. So currently in our system we have 16 GB, 32 GB RAM, but cache size is not like 16 GB, 30 GB. So that is because the cost is very high. Then come the flash memory. Flash memory actually comes after the main memory because we don't really use too much in the real systems. Then come magnetic disk, in which we actually store our data permanently. After that we use optical device. The storage capacity is not as high as magnetic disk, but it is used to back up data, which is not in bigger size. And at the end comes the magnetic tape, which is used for backup the data. Its cost very low, also speed is very low. So when you go up, the speed is high, and go low, the speed is low. So this side we can treat as speed, and when you go take an arrow like this, and in this section we can think of cost is high and cost is low. So this is all about hierarchy. Also magnetic disks are referred as secondary storage, also known as online storage, and the other disks, other magnetic tape and optical devices are tertiary storage, also alternatively known as offline storage. So this is the internal structure of any magnetic disk. So all these disks are called platters. They are fit on a single holder. It is called spindle, and all this platter has two surfaces. Both surfaces we can read. So this surface we can, and the below surface also we can read. And all these platter on both sides, they are divided into different tracks. Okay, and these all tracks are separated by sectors. So whenever we want to read any sector, any track, we have to move this arm to that particular track, and this head has only motion, to and fro motion. So we have to move this particular head to desired or target track. Then this platter is rotated to find the exact sector we need to read. So another thing is that when we move ahead, actually all these head move at the same time. So when a particular head on this ith sector, all these heads will be set on ith sector on all these platter. So we can have the illusion that this can form as a cylinder like this, and all these heads are mounted on single arm, which is called arm assembly. Okay, this is a disc arm assembly, and in this section we can see that the discs are separated by tracks, and then this segregation done to form a sector. Next, whenever data is stored in each block on each platter, on each sector, a particular calculation done on each word, that is called checksum. What is the checksum actually? Whatever the data are kept in form of binary system. So we can add all these words together, and whenever a carry is generated, we add this carry to this result, and we keep on doing until all the words are added up. At the last, when you get the final result, we take a complement of this result. We take complement. So finally, our checksum is ready. So whenever any text try to next time when you try to read, same thing we do for the reading purpose also. And after getting all the sum, at the end if we get 0, that is our data is intact. So what is the purpose of having this checksum? The purpose of this checksum, that we have to know that the data we are reading is errorless. So when data is corrupted, we will get different checksum after reading, not 0. So that is actually indication that our data is in proper form after the writing. So this kind of thing is done by a special controller called disk controller. So disk controller do checksum, and also it do some mapping of batch sector. So after reading couple of time, it happens that some sector will be corrupted. So what will happen, that we have to map this kind of this sectors are batch sector. So we do not allow writing on those batch sector. So this kind of mapping is done by our disk controller. So if we have disks, so we have to attach it to the other system. So for attachment, we have different system. For old system, we used to have PATA. So this is the connector for the PATA. This is the connector for the PATA. And in the disk itself, we had something, this connector. So this font portion which comes attached to this portion, and this is used for power, and this particular portion is used to for jumper actually used to for creating master and slave disk. So if we have uh, more than one hard disk in our system, then we have to make one hard disk as a master and other slave. So so that the master hard disks will have the operating system, and all the slave hard disks will have the data, not the operating system. So for that reason, we have to short both particular dedicated pin to make it a master hard disk. Apart from this parallel attachment technology, advanced technology attachment, we have another technology called Syria, which we have mostly in the current system. So on motherboard we have some interface like that, and we have connector. One end will plug into this interface, another will go for the hard disk. So it is the full form is Serial Advanced Technology Attachment, and for PATA it is Parallel Advanced Technology Attachment. Apart from that, in the old system, another connector is a Small Computer System Interconnect. In form, in short, it is written as SCSI. And for the new technology, some fiber optic channel is there for fast access. We can use it as in server system. So after we have different kind of disk structure or different types of connector, next thing we have to measure the performance. So we performance and measure different parameter. The most start with we access time, this time from which we read or write request is issued, and when data transfer begins. So when we first issue and write, read or write permission. So after that, when the transfer begins, this is called the access time. Seek time, when we try to find a particular sector, the amount of time it requires to go the target sector is called the seek time. Average seek time, when we are doing a number of reading or writing operations, after that if you take the average of all the seek times, that will give us the average seek time. The rotational latency, so previously I told that after getting the head at a particular track, we have to find the sector, so we need to rotate the platter. So the amount of time it requires to find rotate and find the particular sector is called the rotation latency. And the consecutive different rotational latency time, we take the average, we get the average latency time. Data transfer time, the amount of time or the rate at which the data is transformed from disk to the other volatile memory is called data transfer rate. Mean failure time, it is the time, it is a measure how when Amount of time, fill out the disk. It is amount of time that on average we expect the system to run continuously without any failure. That is, before any failure occurs, how much time I have spent reading or writing a particular test. So that is calculated as mean time to failure. So these are the parameters using which we can actually measure the performance of any disk. Okay. So apart from measuring these kinds of performance or everything, so we can optimize the disk block access. So there are two approaches we can follow. One is the sequential access and random access. Basically, you can see that in this particular two access type, we can access any data. Either we follow in sequence access or in randomly access. So both have their advantage and disadvantages also. So apart from that, in both the cases, we can do certain things that we can create some buffer. So in volatile memory, we can create buffer and read a chunk of data at a time, so that we don't need to move our head, seek sector by sector. So that's the way you can create a buffer. Read ahead. What it says that when we try to read one block, it is assumed that the next two or three blocks can be required in the near future time. So we can read those sequence of blocks ahead of our requirement. So that kind of thing we can do most of the time to save our time to locate the particular sector, to move the head particular, because these are all the mechanical system. Hard disks we are doing a mechanical way, so it takes time. So if we do like this, that we read consecutive blocks ahead of our requirement, then we can save much time. So another thing that we can do, that we can fix up by scheduling how we can read the consecutive data, the consecutive blocks from the disk. So to do that, we can have different types of algorithms. One algorithm, popular algorithm, we use that we read in a sequence, one block after another block. So after we reach to the end, we again go back to the beginning and again we read at the sequence. So this kind of thing we can do to save rotational time. Also head movement. So particular algorithms are called mainly elevator algorithms. Another thing we can do, file organization. To reduce the block access time, we can organize blocks in a way that the average access time gets reduced. So what thing I can do, we can associate each blocks in a sequence. All the file blocks will come one after another. So we don't need to move the disk arm head too often. Only we have to rotate the platter. So this kind of thing can be used to reduce the access time. Volatile write buffer, whenever we do any transaction, so all the writing has been done, all the writing has been done for into the buffer, which is in the main memory. So it is a volatile space, so need to write these blocks directly to the particular dedicated space on the hard disk. So another, we can use log disk. So when you write in the volatile write buffer, what we will do, we increasing commit, block commit over it. So we have to write whole block to the disk. So in spite of doing that, what we can do, all these interaction, all these kind of operation, we can write it down on the log file, which is in a very less memory compared to the block. So we can write this log, and that log can be saved a particular space. We call it a log disk to save time. So these are the way we can improve the speed of block access. Now we come to the file organization. That is, so far we have discussed how we arrange the different types of stable storage or offline online storage to store the data. Now next thing we have to discuss how the data are organized in a file. So file is just nothing but a logical sequence of records. Why it is logical? Because we are thinking that records are kept in a one after another logical fashion. At which address it is located totally dependent upon physical layout or physical structure. Each file is also logically partitioned into, so we divide each file into logical partition, we call it blocks. So a block can contain several records, may be part of single table, may be part of different table. Records physical layout can be of two types. So now comes the important thing, how we can physically keep this record. So in a record, it consists of number of attributes values. So I have to decide how we can store these attribute values in a particular record. So it can be stored two way, fixed length records and variable length records. What happens in the fixed length record? From the name we can realize that the blocks size would be fixed, also the length of the records also fixed. Now when we have something like fixed size blocks, what happens that if the record size is not exact size of the block size, then so many spaces will be unused. So that will create a problem which is known as internal fragmentation, which is called internal fragmentation. So in this problem, another problem, particular record is deleted, then what we do, we shift all the remaining record one place up. So in this example you can see that there are 11 records. So if I delete record number 3, what we have to do, we have to move all the record from 4 to 11 to up to occupy the empty space which we have got after deleting this record. Yeah. So you can see there is a no record 3 and all these records move up. Okay. So this is the one way you manage after deleting any record in fixed length record system. So in the previous system we have seen that we have to move all the remaining record one place up. So that is the time consuming thing. So what is the solution? That we can move the final record, the record number 11, to fill this empty space after deleting record 3. So that will save your time. We have to move only one record, not all the rest of the thing. But even that we have problem, like it is okay when we delete only one record, but what will happen if we delete a number of records? To manage that we have to follow different structure. To do that, we at the beginning of the file we have to maintain a special placeholder called header. So the header will indicate the first empty space after deleting record number 1. So this record number will indicate again the empty space record number 4, and again it indicates the record number 6. So we creating a chain of free space, and also we can see that after deleting also we don't need to move any record to fill this empty space. So what is the advantage of having like this structure? So these places are empty and we create a chain of empty space, and whenever any record, any other record are inserted, we follow this chain. So the last chain is here. Next record, if record number 12 we want to insert, we insert here. Record number 13 will go here, something like that. So this is the fixed length record keeping system. So fixed length record always produce internal fragmentation. To remove this problem, we can go for variable length records. For that, in the variable length record, we have different kind of advantage, like storage multiple record types. So if in the record types we have integer, then varchar, varchar. In the varchar we know that it supports variable length of data. So in one particular record we can have 10 bytes for the name, and the next record we can have 30 bytes for the name, something like that. Record types that allow repeating fields such as array or multiset. So we can also store array or multiset types of data in variable length structure. So what is the problem in variable structure? That how to represent a single record such a way that individual attribute can be extracted easily. So if length is not fixed in the variable mode, so we need to know at which the particular attribute value has started. So that kind of information is important. So this is the first problem. Then how to store variable length record within a block. How we can store a particular record within a block. That two types of challenges we have to face if we want to implement variable length records. So in a particular record we have stored four attributes: salary, ID, name, and department name. So in this particular structure, the first beginning should be of fixed size records. So what is in there in the first record? This is the 21 represent the beginning of this ID record. Here ID, name, and ID. This is ID, name, and department name. All are type of varchar. So for that we need to know where it has started and also the length of the data. So in this case ID has started from position 21 and length of this ID is 5. Okay. So name has started from 26 and length of the name is 10. And the department name has started from 36 and length is 10 also. So these are the fixed information, and we can assume that this is offset and this is the length. So offset and length will require 2 by 2 byte each, so total size is 4 byte, and in this case also 4 byte. And we have assumed that ID salary requires 8 bytes. So this is the your actual physical layout for the record, for a single record. And in this case particular 21 to 20 to 21 we have particular value string of sequence of zeros. This is used for indicating null value. Suppose this salary data is null, so we have to set this last bit as 1. This 1 indicates that salary data is null, so even if there is a data we have to ignore it. So that will happen if ID is null, then we have to set this is 1. If name, this is 1. So for each attribute we have to set 1 here to indicate that that value is null. So this is called null bit string. Also in this particular case we have 4 records, so there are 4 zeros. If we have 10 attributes in a record, so we have to maintain 10 zeros. So it will change according to our design or type of the record. So next thing is that how variable records are stored in a block. So it has a particular structure. So what we do, the beginning record entry, the number of record entry there. So what are the number of record? It goes here. Okay. This particular space indicates this area, the end of the free space, and array which actually indicate this kind of record. Now these record, they are not holding actual records, they are holding physical address of actual data. So this is the technology we use to store variable record in each block. So we have to create this kind of structure in each block for variable records. Now we have different kinds of organization for files. In the heap files organization, any record can be placed anywhere in the file. Where's the space for the record? There's no ordering of the record, so we don't follow any ordering. We just keep any record anywhere. Sequential file organization, we actually maintain an order in which sequence we are actually storing the data. So ordering can be done. We know that the key attributes actually indicate the unique data. So we can use that key attribute to order the record. So we call it search key. Okay. And the hash file organization, hash function is computed on some attribute on each record. The result for the hash function specify in each block of the file. So what is happening that for each, suppose each disk have different kinds of block. So block 1, block 2, block n. Suppose for a file we need n numbers of block. File A, n numbers of block. Now the challenge is we have to store record in one of these blocks. So next thing we have to do, how to compute or how to know which block will be selected. That is done by hash function. Hash function will generate particular block ID at which our record will be stored. So that the file in which we follow this kind of technology we called file hashing file organization. What happens in sequential file organization? Sequential file organization, they are ordered depending upon search key. So already talked about that. Search key may be any attribute or set of attribute. Mostly we use primary key or super key. So records are nothing but chain of pointers. So this is the first record. It contains the link of the next record. Again it contains the next record. Again next. This way we can link all the records in our file. So what is the advantage of having this chain of pointers? Suppose these blocks are not in a sequence at a physical storage device. So even if they are not located in a sequence, we can have an illusion they are in a sequence. So we can see that in this particular block they are not in a sequence, but what we did, we create a chain to this block and again this chain to the next record. So we have the illusion this block comes after this block. After this block comes. So even if they are not in a same physical sequence, maybe some random space. So that is the advantage of file, this kind of chain system. Also, even if you delete any record, we don't need to move records. Only few pointer adjustment is enough. Okay. So since we are creating only chain of pointers, so we create a linked list like structure. So even if they are not in the same sequence, we can have illusion that they are in a sequence. Now problem is that if we store a single table in a single block or some data, some records of a single table in a block, then at the time of joining, when you need to read two different blocks from two different tables, we need to perform two different blocks in a sequence. If this joining takes more than one block read, then for one table we need to read 3 blocks and the next table we need to read 4 blocks. Okay. So what is happening here, we need to read different blocks for different tables. Now the question is, can we do something to improve this multiple block reading? Because when you try to read the block, if it is not in a sequence, we have to move our head also, which is very time consuming. So to reduce these things, we can do that. We can keep related records in a single block. So in each portion we can write table 1 data, and another side of this block we can keep table 2 data. And this one of these data, one of the attribute for both the table, they are linked. So when you perform the join operation, we need to read only this block in spite of reading two separate blocks. If you don't do this, we have to read two separate blocks. Then we do this joining operation. But in this case, the related records are the same block, so we have to perform only one block reading. So this is the multi-table clustering file organization. In this scheme, we actually keep related data in a single block to reduce the access time. The next thing is data. What is data dictionary? So what we are doing in the database, we are keeping the information about practical real problem. Suppose we are keeping information of a student, employee, something like that. So we are creating database for that. So even if we create the database, we have to know certain information about the database itself. So that data, whatever we keeping for the relation, is called the metadata. It is something data about data. We call it data about data. So we are keeping the information about the structure of the relation in a database. So we call it metadata. And this structure in which I am keeping this information is called data dictionary and system catalog. So what types of information usually we keep in data dictionary? The name of the relation, attribute on each relation, domain and length. Domain means the type like integer or variable character type. These are the domains. Domain and attributes, then name of views defined on the database, and if we create views or any kind of thing trigger, then we can keep those information. And integrate different types of constraint, triggers, cursors, procedure functions applicable to any relation. We can keep those information also in the data dictionary. So data dictionary gives the detailed description of our structure, what kind of information we have for a particular relation. So if we want to keep those information, we have to use this technology. It's called data dictionary or system catalog. So this is all about this file structure and file organization. Thank you.